this problem, we would like to solve a joint variation application. This problem says the cost of constructing a 9-foot by 12-foot patio is $734.40. If the cost varies jointly as the length and width, then what does an 8-foot by 14-foot patio cost? First, what I would like to do is identify all of the variables in question. I have several variables to note. First is the cost. The second one is the length, and the third is the width. The other key phrase here is varies jointly, which I will address in just a moment. Just to remind myself, I have C is the cost. I'm choosing variables. L is the length. And W is the width. Now that I've assigned variables for all of these important quantities in the problem, I can use the information given to me to set up an equation. Varies jointly means that each of these length and width quantities are going to be multiplied by each other times another constant of variation to equal the cost. What I mean is we will have cost equals K times L times W, where K is the constant of variation, which occurs in any variation type of problem. Now I'm going to use the information that's given to me in the initial setup. They say the cost of constructing a 9-foot by 12-foot patio is $734.40. So instead of C for cost, I'm going to write $734.40. And I want to find out what K is. So I'm going to put K there. I know the length. The length is 9 feet. And I know the width is 12 feet. Calculating for K, I get K equals 6.8. I can then use this information to figure out how much a patio that has 8-foot by 14-foot dimensions costs. So I'll plug that into this equation, but now instead of having a K, I'll put 6.8 in for K. So I want to figure out the cost, and I have 6.8 times 8 times 14 in this case. Multiplying these out gives me 761.6. Or in other words, the cost of an 8-foot by 14-foot patio to construct would be about $761.60. In this problem, we use the idea of joint variation in order to solve an application.